Alright, so we just discussed the confidence procedure, and I had shown you a little bit how to carry out the confidence procedure. So what the confidence procedure is telling us is that our measurement is really about 3.3 centimeters, and anything beyond the tenths place really isn't giving us any information that we truly have, because there's too much variability beyond that. And if you look at these numbers, most of you would agree that it's right around 3.3 centimeters. In fact, probably without having taught anything about the maximum capability of a measuring ruler, most of you would have looked at this and said, yeah, it's probably around 3.3. Well, that captures your sort of innate sense that beyond the 3.3, there's not much point in recording the hundredths place. Now, the confidence procedure really can't be used if you make a single measurement. And so we're going to have a general rule, which is that. So our general rule is going to be, when you're making one measurement, a single measurement, not three repeated trials like this, but one measurement, you're going to use the maximum capability when recording your measurements. In other words, if we recorded this only once, we record it down to the hundredths place. We can't be sure to do with anything else. However, when making three or more measurements, we'd like you to use the confidence procedure to tell you what place value to record your measurement to. Period. All right, let's take another look at this with yet another example. Here's a track, and a guy is going to run the track. So here he goes, ready, set, go. 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. And in that first run, let's say that it took him time. Say it took him 13.15 seconds. And let's say we had three repeated measurements, 11.23 seconds and 12.01 seconds. Now you can see there's a lot of variability. That variability could be in our ability to start and stop the stopwatch when he crosses the finish line. It could be due to the fact that he's running different speeds, slightly different speeds each time, or both of those. But regardless, we have a lot of variability. I think most of you can see there's hardly any point in recording the speed of this runner down to the hundredths place. If the question is how much time did it take him to run this distance, there's not much point in recording the hundredths place because there's so much variability even in the ones place and the tenths place. So let's use the confidence procedure to see how we should record the average time. First, let's take the average time. And you can go ahead and do this in your calculator. But let's record the average time here. And if we take the average of those, we get 12.13 seconds. But again, as we can see from these numbers, there's no way we're confident of his time down the hundredths place. So let's use the confidence procedure to see how we should actually record that. That's sort of like a rough draft average. All right, so the confidence procedure tells us that we should create a range around this number. So let's start with the tens place. So we want a range of 5 tens, which is 50, and so we want plus or minus 50 around there. All right, so 12.13 plus 50 gives 62.13, and 12.13 minus 50, well, we can't have a negative time, so let's just write 0. So now we have a range of between 60.13 and 0. Are we confident the next time he runs we'll get a time within there? Well, yeah, all the existing measurements are easily within there. So yes, we are very confident the next time he runs he'll be within there. That is to say that we're confident that his time down the track is good to the tens of seconds. All right, and then in the next part of the video we'll pick up the other place values.